Hey there, grade six. New video for you guys today. This one focuses on measuring angles. It's the next lesson in the geometry unit. And so our goal for the end is that you are able to measure and create angles using protractors. And so you will need some kind of measuring device at home that can measure angles, preferably a protractor. If not, maybe you can ask someone to pick one up for you because they are kind of handy and very useful when we measure angles. Okay, so here are the first set of angles that we're going to look at. Just a quick reminder, angles have two arms, or two that are made up of rays, and those rays share a common vertex. So the question is, which angle is larger? And it is pretty hard to tell. I think you can probably see that this one is a wee bit larger, but it'd be hard to tell, but this one actually has a measurement of 35 degrees, and this one has a measurement of 30 degrees. But if they're not labeled, man, it's tricky to tell. So then how can we measure how much something turns? Which is kind of an interesting way of thinking about how we start measuring the sizes of angles. And so when we measure how much something turns, if we use ourselves as the center point, and if we imagine that we have ourselves kind of out in the middle, or sorry, if we have our arms pointing out, we kind of measure stuff in terms of like a quarter turn or so if this is us in the middle and we have our arms pointed mostly straight out, we say, well, we can do a quarter turn, go all the way, and do a half turn, go, the next little bit would be a 3/4 turn. Or if you go all the way around, then you have, I guess, 4/4 or a full turn. Okay, and so that's, I guess, kind of the way to sort of measure that. And so we do talk about quarter turns, half turns, right turns, etc. When we measure angles specifically, we have these things called degrees. That's the unit for measuring angles. And so if you actually just stop for a quick sec and look at the picture in your book, it's on page, it says 65. I think it's actually 95. It's not 65. If you look at page 95 in your workbook, it shows you a 1-degree angle. And it is like this thing, there is like this, this is not going to be super straight, but it's like this one ray and then this like other one that's really close. And I think that the measurement, I can't remember, I think the measurement's up there, but that's like a 1-degree angle. And so what they basically did was they, took a center point. I'll just change the color for a second. Took like a center point and then said, well, okay, there are like a whole turn, and they just sort of like decided to divide it into 360 different degrees, right? And so that's what they decided to divide this circle into. Okay, so what you do is you divide a full turn into 360 equal divisions, and so every one of those divisions becomes a degree, right? And so if this is where we start, if we go up a quarter turn, that's a quarter of 360. So that's why we say that that's 90 degrees, right? If we go a half turn, half of 360 is 180 degrees, which is sort of how we get to those numbers that we work with. So just a quick reminder that a right angle is 90 degrees, a straight angle is 180 degrees. If we go back to this one, a 3/4 turn would then be 270, and then a full turn would be 360. Okay, so just so we are aware. So what you can do if you would like is to pause it here, just work on question 1 in the workbook on page 95. Also understand that writing the word degrees, that it takes time. So there's a symbol. It's not all the dash. It's just this thing, this little circle. It means degrees, right? So 90 degrees is 90 with that little dot. Excuse me. The next thing that we work on after we sort of finished up number 1 is starting to look at these words that talk about a specific sizes of angles. Okay. So the first word here, acute, it means all of the angles that are less than a right angle. So everything from 1 degree up to 89 degrees, those are all acute angles, okay? Then we have a right angle that we know. So that's 90 degrees, that's a specific angle. Then you have obtuse angles, and that's everything that's bigger than a right angle, but less than a straight angle. So it's everything from 91 degrees to 179. Then you have your straight angle, which is 180 degrees. Again, it's very specific. And then beyond that, you have reflex angles, and that's everything that's 181 degrees, up to 359 degrees. Okay, and so over here, this is an acute angle because it's less than 90 degrees. This is a right angle. This one's going to be an obtuse angle. Okay, so again, right, very specific. You have that little symbol. These are sort of our angle symbols. But again, acute, right, obtuse, very specific. Okay. So these two are acute, right? Because they are bigger than 1 but less than 90. This one is bigger than 90 but less than 180. It's, I don't know why I wrote a B. It's obtuse. Okay, and again, we start looking at more or less than 90 degrees. This is less than 90, more than 90, more than 90, okay? Now, the next question here is, how could you tell which is longer? And so what we normally do is we would get a ruler. We would just get the ruler tool, which I think is here somewhere, right? We get a ruler tool and we would measure it in centimeters. In measuring angles, we use something called a protractor, and you'll notice that this protractor, like pretty much all protractors, has an inner and an outer scale, and each of those scales is half a circle, so it's 180 degrees again. So 0 to 180 on the outer edge, and then 0 to 180 on the inner side. It's similar in that it measures stuff. It's different in that it measures degrees and doesn't measure a straight line. Okay, and so here we have this dotted angle, and so it kind of opens to the left side, and so in that case we like to use the outer scale, not the inner scale. Angles that open to the right, typically we use the inner scale. So this one, it says that this is a 30 degree angle. Okay. This one, notice that this one kind of opens to the right. So it's lined up, the baseline is lined up at 0, and then we go all the way up. This one is, I didn't really mention this before, but it looks like we have two options. We have a 60 degrees right here, and then we have 120. Now what we have to do is look at this angle and say, well, is this acute, obtuse, right, straight, whatever? This angle is obtuse, which means that the number has to be bigger than 90, but less than 180, and 60 is not those things. It's 120. So we would say that this angle is 120 degrees. And so that's really a kind of a key point to look at an angle, recognize if it's acute, right, obtuse, straight, etc., to figure out which of the two, like the outer or the inner scale, you should be using. So at this point, you can work on 5 to 7 if you would like, because it focuses on the protractor stuff. The last thing that I want to show you guys here is just measuring using a protractor, in case you're unfamiliar or it's been a while. So this point, let me just get this here for a second. This point here, this is called the origin. And what we do is we always have to line up the origin with the vertex of the angle. And then we have to line up the bottom arm of the angle with what's called the baseline of the protractor. And so I'm going to do that. I'm going to move that down and line it up here. And now this angle opens to the right, so I'm going to use the inner scale. I recognize that this angle is acute, so it's got to be less than 90. And I have a number here that looks like it's between 50 and 60. So I'm going to say that this is a 55 degree angle. And that is how I use my protractor. That's for an angle that opens to the right. It if the angle opens to the left, then you have to use the outer scale. Okay, so don't forget about that stuff. Anyway, I think that that's about all you need. You can work on the other questions on 95 through 97. It sounds like a lot, it's 3 pages, but it's mostly identifying if an angle is acute or obtuse, if it's right or if it's straight or reflex. It's really helpful to have a protractor. So try to find one around your house if you can. Otherwise, you want to skip the actual measuring questions, but please try to do them if you can. That's all I have for this one. So thanks for watching, and have a great day.